Introducing our innovative product, LPS PCSK9 Atherogenesis Kit, the experimental model for studying in vitro atherogenesis biomarkers expression through PCSK9 enhancement using lipopolysaccharides. This project is led by Prof. Datin Dr. Hapizah Nawawi with other team members AP Dr. Suhaila Abd Muid, AP Dr. Wang Seok Mui, and Ms. Rahayu Zulkapli. According to WHO, cardiovascular diseases are the #1 leading causes of death globally, responsible for 8.9 million deaths, which equal to 17 deaths per minute. Thus, research related to cardiovascular disease is very much needed. The most common cause for CVD, including CAD, is a vascular injury with cholesterol plaque built up in the tunica intima arteries known as atherosclerosis. Overexpressions of inflammation, endothelial activations, and dysfunction have been established as a key event in the initiation and progression of atherosclerosis. Therefore, our experimental model focuses on this biomarkers detection. Other than early atherogenesis biomarkers, PCSK9 has been reported to play an important role in the development of atherosclerosis. PCSK9 is a novel compound discovered in 2003, and the hepatic PCSK9 expression was found to be upregulated in conditions of excessive dietary fat consumption, which happen in many CAD patients. PCSK9 is synthesized in the liver cell, specifically within the rough endoplasmic reticulum, which is crucial in producing many proteins, and PCSK9 is one of them. Once synthesized, PCSK9 undergoes processing and maturations in the Golgi apparatus before being released into the bloodstream. PCSK9 is vital for cholesterol balance, as it can be both increase or decrease the presence of LDL receptor on the liver surface. The significance of PCSK9 became evident in 2005 when researchers identified families with severe early onset heart disease with extraordinary high cholesterol. This family had gain-of-function mutations in the PCSK9 gene that intensify the effects of PCSK9. Conversely, some families exhibited exceptionally low cholesterol level due to loss-of-function mutations in their PCSK9 genes. These pivotal discoveries highlighted PCSK9 as a promising therapeutic target. With PCSK9 present, the endocytosis process is different. PCSK9 binds to the LDL receptor along with LDL particles. Once internalized, this complex is sent to endosome. However, because of PCSK9 present, the endosome struggles to separate the LDL particle from its receptor. As a result, the entire complex is directed to the lysosome for degradation, and LDL receptors are not recycled. This results in a fewer LDL receptors on the cell surface, leading to an increase in cholesterol level. This process demonstrates that disabling PCSK9 by antibodies or impeding its production will reduce LDL cholesterol. There are many ways to study atherogenesis biomarkers, such as animal and human studies. For the preliminary studies, the in vitro is much more suitable and cost-effective. However, currently, there were no PCSK9 involvement and no complete kit was existed to study the early atherogenesis biomarkers. Therefore, our objective is to provide a complete kit that mimics the in vitro condition to study PCSK9 and early atherogenesis biomarker. This kit will contain all the listed items. The LBS provided in the kit will be used to simulate the normal cell lines. Using this complete kit, the protein and gene expression will be measured following this protocol. Further analysis with monocyte binding capacity to HCAD. This is important since the percentage of monocyte binding will indicate the severeness of the plaque development. Our results show that LPS enhances the protein and gene expression of PCSK9, inflammations, endothelial activations and dysfunctions, and the oxidative stress, as well as the monocyte binding capacity. We believe this finding can be translated to its potential as the experimental model for studying in vitro atherogenesis biomarker through PCSK9 enhancement using lipopolysaccharides. There are several usefulness of our kits. The first one is stimulate the process of plaque development in the blood vessel through a molecular pathway that involves protein and gene expression. Second, our kit will benefit other researchers involved in the cardiovascular area in cell culture. And last but not least, it is cost-effective and be conducted in the laboratory. In general, LPS PCSK9 Atherogenesis kit has commercialization potential to be used in many research institutes and research manufacturing companies related to cardiovascular. We have secured the FRGS grant on the PCSK9 and early atherogenesis biomarkers. The copyright application has been submitted in April 2023. Our group has successfully published several papers in Q1 journal related to PCSK9 and heterogenesis biomarker in vitro studies. Aside from that, numerous abstracts have been published locally and internationally on the PCSK9 and heterogenesis biomarkers. We received 4 international awards. In 2022, 1 award from the Academic Science Malaysia for the nomination of Nobel Laureate meetings in Germany. Another 1 awards in 2022 is Young Investigator Awards for Best Oral Presenter from Asian Pacific Society of Atherosclerosis and Vascular Disease. The other 2 awards is Travelling Awardee Fellowship in 2022 and 2023 from the Korean Society of Lipid and Atherosclerosis. That's all from us. Thank you for watching and hope you enjoy our video.